we have discussed some problem of stoichiometry from JEE Main Question Bank from 2002 to 2013. In 2014 and 2015, some questions were also asked from a stoichiometry chapter that we are going to discuss now. In this way, I will complete the question bank solution of stoichiometry chapter from 2002 to 2015. So, the questions asked in 2014 and 15 are, first question was, this is question number 19, if we continue, count from the beginning. For estimation of nitrogen, 1.4 gram of organic compound was digested by JEE method. This is a method you will study in organic chemistry. However, this question is basically from stoichiometry. This if you don't know this method, don't worry. This question will not require the details of JEE method. You can easily solve this problem from using the concept of stoichiometry. I will solve it. Method. And the evolved ammonia was absorbed in 60 milliliter of 1/10 m H2SO4. The unreacted acid require 20 milliliter of 1/10 m NaOH. 1/10 m NaOH for complete neutralization. Similar question was asked in 2004 and I have solved it. In that question, the method was not given, name was not given, and this problem will be solved in that way, exactly that way. The percentage of nitrogen in the compound. There the formula was asked and urea was the answer. Here percentage is asked. A is 6%, B is 10%, C is 3% and D is 5%. And this was the question asked in JEE Main 2014. First of all, you don't have to worry about JEE method. If you don't know this method, the problem will be easily solved. I am solving the problem. Organic compound is taken 1.4 gram and by using JEE method, we are getting ammonia. This is the first reaction. Second reaction, NH3 was reacted with H2SO4 and obviously it is an acid-base reaction. Ammonium sulfate will be formed and concentration used was 60 milliliter of 1/10 m. The ammonia produced in 1 was reacted with H2SO4 60 milliliter of 1/10 m. In third step, unreacted H2SO4, which was unreacted, was treated with NaOH to give Na2SO4 plus water. Na2SO4 plus water, and this is 20 milliliter of 1/10 m. You can easily see how much ammonia will produce by using back titration concept. Valency factor of H2SO4 is 2. Valency factor of H2SO4 is 2. So we can directly correlate milliequivalent relationship, milliequivalent of H2SO4 in those reactions. 2 and 3 implies that milliequivalent of NH3 will be equal to milliequivalent of H2SO4 using 2. and milliequivalent of H2SO4 used in 2 will be equal to milliequivalent of H2SO4 given a minus milliequivalent of excess. Milliequivalent of H2SO4 remained. Now milliequivalent of H2SO4 given is 60 into 1 by 10 into 2 minus milliequivalent of H2SO4 remained was milliequivalent of NaOH. Milliequivalent of NaOH used in 3. So this will be equal to, milliequivalent of NH3 and it will be equal to 12 minus 20 into 1 by 10 into 1. Valency factor of NaOH is equal to 1 because it is a monoacidic base, and hence this will be equal to 10. Now weight divided by equivalent weight, that will be equal to 17 by 1 into 1000, because valency factor of NH3 is 1 here. You can easily see in acid base reaction valency factor is simply acidity and basicity of acid and base. So this will be cancelled out, and so you will get weight of NH3 will be equal to 0.17 gram. So weight of nitrogen in 17 gram you have 14 gram. So in 0.7 gram you will have 0.14 gram. So weight of nitrogen in organic compound definitely in according to question 1 will be equal to weight of nitrogen in NH3. Reaction 1 implies that, reaction 1 tells that the weight of nitrogen in this compound will be equal to weight of nitrogen in this compound, matlab 0.14 gram. So percentage by weight of nitrogen can be easily calculated as 10%. 0.14 divided by 1.4 into 100, that will be equal to 10%. So this is the correct option. B is the correct option. Now after 19. Another question was asked from acid base, which is a very easy question. This question can be kept in inorganic chemistry also. However, among oxy acids, I am doing this question here because I teach acid base salt before acid base titration. Before acid base titration, acid base and redox has been discussed. So I am correct order of acidic strength from inorganic. Also you can see this question, but since I teach acid base salt before acid base titration, so I am discussing this question here. A option is HOCl greater than HClO2 greater than HClO3 greater than HClO4. B option HClO4 greater than SOCl greater than HClO2 greater than HClO3. C option HClO4 greater than HClO3 greater than HClO2 greater than HClO. D option is HClO2 greater than HClO4 greater than HClO3 greater than HOCl. This was also asked in JEE Main 2014. I have discussed previously for oxy acid, most of the oxy acids, there are some exceptions, let's say like phosphoric acid, phosphorus acid. Acidic strength, in case of oxy acid generally, acidic strength directly proportional to number of oxygen atom. Higher the number of oxygen atom, greater will be the acidic strength, and this is due to electron drifting. So correct order will be C. It can be explained as by using this one. I am using this two example, and from this you can easily explain this one. Okay, this is HClO2, HClO3, and this is HClO2. Now I am discussing this one. This is called electron drifting. This has delta minus, so this will have delta plus. Again, this is a delta minus because oxygen is more electronegative, and hence this will have delta delta plus. Now, if you keep delta plus on chlorine atom, it will make more electronegative to chlorine atom. It will make chlorine atom more electronegative. Now, 2 delta plus is present on this chlorine and 1 delta plus is present on this chlorine. So, this will pull electron from oxygen by large amount. This will pull electron from oxygen by low amount. Delta 2 minus and delta 1 minus. Plus. This will be equal to plus because electron has been pulled from oxygen. Now, delta 1 plus is greater than delta 2 plus. So, delta 1 plus is greater than delta 2 plus. So, oxygen is also electronegative. It will not be a positive charge on it. Hence, oxygen will pull electron from OH bond. In this case, more strongly. In this case, less strong. So, acidic strength in this case, H plus will be released from this molecule, HClO3. More is the compared to HClO2. Hence, you can see that higher the number of oxygen atom in oxy acid, greater will be acidic strength. This phenomena is known as electron drifting. So, in this way, you can easily tell that answer will be C. Next question was, in which reaction H2O2 act as reducing agent? A option is H2O2 2H plus 2 electron 2H2O. B option is H2O2 minus 2 electron gives O2 plus 2H plus. H2O2 2 electron 2OH minus, and D option H2O2 plus 2OH minus gives minus 2 electron gives O2 plus H2O. Option is A and B. First option is A and B, second option is C and D, third option is A and C, and fourth option is B and D. Answer will be clearly B and D. In both cases, you are seeing that oxygen minus 1 to 0. Self-oxidations mean it is acting as reducing agent. Self-oxidation means it is also losing. If you move electron to this side, it is losing electron and getting oxidized, and hence self-oxidation means it is acting as reducing agent. Answer will be B and D. These are the answers. So this is the 21st question, was also asked in 2014. JEE Main 2014. You can say the JEE Main 2014. Now, next question is, was the ratio of masses of oxygen and nitrogen in a particular gas mixture is 1:4. The ratio of number of their molecules is A option 1:4, B option 7:32, C option 1:8, and D option 3:16. These are the 22 questions. 22nd question that I am discussing in stoichiometry. Question is telling that the ratio of masses of oxygen and nitrogen. Mass of oxygen and mass of nitrogen is 1:4. then number of mole of oxygen, number of mole of nitrogen will be equal to mass of oxygen divided by 32 and mass of nitrogen divided by 28, and hence it will give mass of oxygen divided by mass of nitrogen into 28 divided by 32. So it will give 1 by 4 into 7 by 8, and hence it will give 7 is to 32. This will be the correct answer because number of molar ratio will be equal to molecular ratio, because molar ratio and molecular ratio differ with Avogadro constant, which is same with all atoms. So whatever atoms you will choose, either oxygen or nitrogen, you will have also always Avogadro constant as 6.02 to 10 power 23. Number of molecular ratio or number of mole ratio will be same. This will be the answer. Now two questions we are asking in 2015. Question number 23. In Carius method, again you don't need to know about Carius method, just like I have told you for Kedel-Dye method of estimation of halogen. This is a organic method of estimation of halogen in organic compound. 250 milligram of organic compound, 250 milligram of organic compound gave 141 milligram of AgBr. 140 AgBr. The percentage of bromine in compound is A option is 48%, B option is 60%, C option is 24%, and D option is 36%. This is the question asked in JEE Main 2015. Look, in question is it given that organic compound has 250 milligram and it is giving AgBr of 141 milligram. You can easily see that weight of bromine in organic compound will be simply equal to weight of bromine in AgBr, and weight of bromine in AgBr will be equal to 80 is the atomic weight of bromine and its molecular weight will be 188, because 108 is atomic weight of Ag and atomic weight of bromine is 80. So if 188 gram has 80 gram of bromine, so 141 gram has 141 milligram has this one. Now weight of compound has been given, so percentage by weight of bromine will be simply calculated as 80 into 141 divided by 188 divided by total weight 250 milligram, ऊपर नीचे milligram है कोई, then there is no issue. So we will have 80 into 141 divided by 188 into 250 into multiplied by 100 and cancel. So the answer will be approximately, you can solve it, you can calculate, this is 2, this is 5, so 160 into 141 divided by, I am 188 into 5, that will be equal to 9, 4 and 9, 940. This will be cancelled out and this will be equal to this will be simply equal to 1694 approximately 6, and if it is 6 then it will be equal to 2 and 24 approximately 24%. This is the correct answer. Approximately I have solved that because it is not need to solve exactly this relation, because you have to do answer in approximate region. If you are getting, I am telling you the calculation like 16 multiplied by 696, then I can approximate that 16 into approximately 25, 24, 24 will be equal to this one, so then answer will be equal to 24%. Next question and last question of stochiometry till 2015 is the molecular formula of a commercial ration used for exchanging ions in water softening is C8H7SO3Na. molecular weight जो होगा हो गया 206, given as molecular weight is 206. What would be the maximum uptake of calcium 2 plus ion by the ration when expressed in mole per gram of ration? A will be, A option is 202 by 309, B option is 1 by 412, C option is 1 by 103 and D option is 1 by 206. This is the question asked in JEE Main 2015. You know that water is softened by ion exchange method, and hard water which has calcium 2 plus ion present is softened by C8H7SO3Na, whose molecular weight is 206. So question is, what is the mole of calcium 2 plus that can be extracted out by this one? You can easily see that the formula of this will be equal to 2 calcium. So it will be 2. 1 mole of calcium 2 plus is taken by 2 mole of C8H7SO3Na, means 2 into 206 gram of C8H7SO3Na. So if the expression is written as mole per gram, mole of calcium 2 plus expression per gram, so 412 gram of C8H7SO3Na has uptaken 1 mole of calcium 2 plus. So 1 gram of this one will be taken, this one mole of per gram of calcium. So answer will be B. So this is the correct answer. So we have solved all the questions that has been asked by JEE Main or EEE from 2002 to 2015. In next class we will solve other problems of other chapters of JEE Main.